Alright, welcome back. So in our previous video we took a look at how to do weak acid calculations, and in this video we're going to take a look at how to do weak base calculations. Now a weak base calculation, we're just going to ignore a few things for a moment. So we're just going to cover this stuff up here. When we're dealing with a weak base, you tend to be asked to solve the OH minus concentration. That's usually what we're trying to figure out. And so when I show you the example that we're about to do, you're going to see that it eventually asks you, what is the concentration of OH minus? And so let's take a look at the example. A solution of ethylamine, C2H5NH2, is prepared with a concentration of 0.250 molarity. What is the concentration of OH minus if this is our initial concentration? Sorry, I wrote it twice. Just wanted to really make sure that you knew it was 0.25 molarity. And it tells us that the Kb is 6.4 times 10 to the minus 4. Now, remember, the first question you should always ask yourself is this an acid? Is this a base? Ethylamine is not super clear for those who aren't like really well versed in chemistry, but amines, things that have NH2s at the end, those tend to be bases and act like bases. So that's one clue. The other clue is it actually tells me in the question Kb, the constant for a base, is this number. You could also look this up. You could look it up in a table and do your calculations. But the other thing is because it asks me for the OH minus, I know I have to use the Kb. Okay? So previous video, what I showed you how to do was how to use an icebox to never use an icebox ever again when it came to acids and bases. And this time I'm going to do this question, no icebox. I'm just going to show you how you can plug in the values and get to that answer. But to do this, the first thing we need is an equation so that we can build our Kb. And let's be honest, it's chemistry. Write a balanced equation every question. You should always do that. Don't even ask at this point. If your question is, should I make a balanced equation? You already know the answer. The answer is always yes. Remember, all of these reactions are reacting with water. Base reacts with water. Weak base reacts with water, so it's in equilibrium. Bases accept protons, so water loses the proton and becomes OH minus. This accepts the proton, and it's going to become C2H5NH3 plus. Okay, a common question is, how do I know where the H actually goes? Does it go in the front? Does it go in the middle? Does it go in the back? The H actually attaches to the nitrogen, and so that's why I put NH3 with a plus charge. I put the 3 after the N, because these H's are all connected to this nitrogen. That's because I know what this molecule looks like. I can visualize it. If you don't know that, I wouldn't be worried too much about where you put that H. Okay. Rule of thumb though, if there's an NH2, that's the thing that's going to pick up the hydrogen. Ultimately though, I wouldn't be too concerned about that. If your instructor is so worried that you put the H in the wrong spot and you did the rest of the question right, I think they're focused on the wrong thing. So let's take a look at how we would do this calculation. We're dealing with the Kb, which is an equilibrium constant, so it's going to be products divided by reactants. So products are going to be OH minus and C2H5NH3 plus divided by reactants. Remember, water is a liquid. Water doesn't go in the equation. So it's just C2H5NH2 on the bottom. A few things I should mention right here. When you're dealing with a base, you should always have OH minus as a product. So OH minus should always be on the top of your Kb. Conjugate acid should be the other product. It should always be on the top. The original base should be on the bottom, and you should not have water in the equation because it's a liquid. When you're making this, it's really important, don't get these things mixed up, right? I know they look very similar, so just make sure you sort that out before you're doing this ahead of time. Double check your Kb to make sure you've done it right. And now we can actually plug everything in. So instead of Kb, I'm going to write the actual number value for Kb. So 6.4 times 10 to the minus 4. Okay, think back to the last video. Remember, concentration of products starts at 0, increases by positive x, and becomes positive x by the time that equilibrium is reached. Remember, this would be the original concentration minus the change, but we're assuming the change is so small that it's not going to make a dent in this number. So we're just putting this number down here. Now, this is what I like to do. You know, in my class, I wouldn't ask my students to do more than that, because I don't want them to have to solve a quadratic every single time that they're doing an acid-base calculation. But talk to your instructor, find out what they expect. If you're in university, you should do the quadratic. If you can't do that, then you need to brush up on your math skills. And let's face it, you're just like punching it into a quadratic solver on the internet anyway. You're not actually going to be like solving it or anything. You're not punching it in the formula. Let's be real. Okay. So here's what we're going to do. We're now going to solve. And so to solve this, I'm going to multiply by 0.250 on both sides of the equation. That's going to cross this off. I'm going to have x squared 0.25 multiplied by 6.4 times 10 to the minus 4 is 1.6 times 10 to the minus 4. Now to solve for x, we take the square root. So we square root that number, and we get an x value of 0.0126 molarity. Now, remember, x is the concentration of OH minus. So the concentration of OH minus is 0.0126 molarity. Now, we should point out the assumption we made is actually not a good assumption in this case. Because if I took 0.126 minus this number, minus 0.250, that's actually going to change 0.250. In reality, you should do a quadratic for this equation. But let's be real too, we're doing grade 12 chemistry. We're not trying to make things super complex. But if you actually wanted to know the real answer, you could plug this into the quadratic equation and solve for it. But here's what I wanted to do. I wanted to make sure we know why I did what I did. First thing is I knew I was dealing with a weak base. So I created a balanced equilibrium equation that produced OH minus. I used my Kb because I'm working with a base, with products on the top and reactants on the bottom. The products are going to increase by a factor of x, and they start with a concentration of 0. And so we put x's on the top. We assumed that x was very, very small compared to this number, and so we don't have 0.250 minus x, right? Because that's normally what you would have. Think back to your like initial column for C2H5 NH2. I'm just going to do this real quick on the side. You would have 0.250. It's going to decrease because it's a reactant. It's going to decrease by a factor of x. And so at equilibrium, it should be 0.250 minus x. But remember from the last video, we assumed that that number was so small it wouldn't make a difference. And that's why we chose this number to plug in there. From there, we just do algebra, we solve for x, and that's our concentration of OH minus. Like I said, this wasn't a good assumption this time, but we're going to make this assumption every time, and you should just be aware if you move forward and do more chemistry later on, that that assumption isn't always going to be true. That's part of science. We make assumptions once in a while, and it makes our life a little bit easier. In this case, it gave us an answer that technically isn't great, but for purposes of what we're doing, it's good enough. Okay? What you should definitely do right now is go and practice doing weak acid, weak base calculations. That is like the most important thing that you can do right now is make sure you know how to do this before you move on. Do not jump ahead to the next material until you feel confident that you can solve both weak acid and weak base calculations, and I should throw in there too strong acid, strong base calculations. One of the biggest mistakes people make when they're dealing with chemistry of this style is they treat a weak base like a strong base, or they treat a weak acid like a strong acid. That's why I've told you, first thing, always check. Is it an acid? Is it a base? Is it strong or is it weak? Ask yourself that question before you start every single problem, and it'll lead you down the right path. Okay? So tune in next after you've done some practice to learn about the equilibrium of water and how that changes everything for us. Thanks. See you next time.